Hi everyone. Today a look at the organization of the table of standard reduction half reactions and how we can use that table to predict whether or not a redox reaction is going to be spontaneous or not. This is a copy of the table that we can find in the data booklet on page 7. It's called a table of selected standard electrode potentials, and it has quite a long list of reduction half reactions. When we look really closely at this page, we see that there's double-headed arrows. It's important to say that these half reactions are not at equilibrium. This double-headed arrow just means that we can read the table from left to right as reduction, or we can read it from right to left as oxidation. The order of the chemicals is such that on the left-hand side of all of these arrows, on the left-hand side, we have oxidizing agents, where the strongest is at the top. It happens to be fluorine gas, and then these oxidizing agents get weaker and weaker and weaker as we go down. So we find the weakest one at the bottom, lithium ions. On the right-hand side of the table, the right-hand side of the arrow, we have reducing agents. This time it's upside down. The strongest reducing agent is at the bottom, lithium solid, and this time they get weaker and weaker as we go up. So the weakest reducing agent is at the top, fluoride ions. It's important to note that some oxidizing agents and some reducing agents are a combination of two chemicals. Especially here in the top left-hand area, we have many situations where we have an anion in combination with hydrogen ions acting as fairly strong oxidizing agents. There's a few places where water is included, maybe we have hydroxide ions, so we need to be on the lookout for times where it's two ions in combination that are acting as either an oxidizing agent or a reducing agent. In addition, there are a handful of substances that are both, that show up on either side of the table. One example is water. Liquid water can act as an oxidizing agent. I'm finding it here on the table. And up here, I'm finding it as a reducing agent. There's a handful of other situations like iron 2 ions or copper 1 ions. So as we move forward in the unit, we are going to have to be conscious of those few chemicals that can act as both. When we have net ionic equations given to us, well, our job is to identify the oxidizing agent, identify the reducing agent, and actually locate them on this table. We need to find them right on here. Then, if the oxidizing agent is literally higher up on the table than the reducing agent, that's going to indicate to us a spontaneous reaction. If it's the other way around, and the oxidizing agent is lower down on the table than the reducing agent, that's a non-spontaneous reaction. I have two examples for us to think about. We have zinc solid reacting with calcium 2+ ions to produce zinc ions and solid calcium. Our first task is to decide which one is the oxidizing agent and which one is the reducing agent. We can go about that in a couple of different ways. We can analyze the reaction itself. We have neutral zinc atoms becoming zinc ions. How did they do that? Oh, they lost electrons. And a loss of electrons is oxidation, and the substance that gets oxidized is the reducing agent. One possibility is to analyze the reaction itself to come up with these labels. By a process of elimination here, the calcium ions would have to be the oxidizing agent. If we dig a little bit deeper, we can see that the positive cation turned into a neutral atom. It did that by gaining electrons, by getting reduced, which means it's the oxidizing agent. Our second strategy, however, is to search the table for zinc solid. We're going to have to find it anyways, So where's the zinc solid on the table? It's very specific. We cannot look at the zinc ions. We must find solid zinc here on this table. It's right there. Now, I need to find calcium ions on the table as well. Ca2 plus aqueous. Where is it? Right there. By doing that, I get confirmation that my labels are correct. The calcium ions are on the left-hand side. That's where we find oxidizing agents. The zinc is on the right-hand side, which is where we find our reducing agents. So I get confirmation that my labels were correct. Now I can also tell that the calcium, the oxidizing agent, is lower down on the table from those zinc ions. And if the oxidizing agent is below the reducing agent on the table, we get a non-spontaneous reaction. So this first scenario over here is non-spontaneous. A second example, silver ions reacting with hydrogen gas to produce solid silver and hydrogen ions. My first strategy is to look at the reaction really carefully and decide which chemical is which one's the oxidizing agent, which one's the reducing agent. My other strategy is to find Ag plus right here on this table. I might spend some time searching just because I might not be familiar with everything that's on this table. And that's okay, I can take my time. Eventually, I'll find it. Silver ions are right there. They're on the left-hand side of the table. They're an oxidizing agent. So I can put my label in here. The silver ions are the oxidizing agent. How about H2 gas? Well, if the silver is the oxidizing agent, the other one has to be the reducing agent. I need to find it right here on the table. There it is. The hydrogen gas is a reducing agent. Now that I've found them, here's the oxidizing agent, here's the reducing agent. The oxidizing agent is higher up on the table than the reducing agent, which means it's a spontaneous reaction. Spont for short. So we have this table of reduction half reactions, which we can find in the data booklet on page 7. We can read it from left to right as reduction. We can read it from right to left for oxidation. The left-hand side of the table is where we find our oxidizing agents. They're in order, with the strongest at the top getting weaker and weaker as we move down. It's the opposite for the reducing agents. The strongest is at the bottom, and they get weaker and weaker as we go up. When we're presented with net ionic equations, our job is to actually locate the chemicals involved right on this table. And then if the oxidizing agent is above the reducing agent, like our second example, we have a spontaneous reaction. However, if the oxidizing agent is lower down on the table than the reducing agent, we get a non-spontaneous reaction. And I hope that helps.